Now we'll speak about Neo4j and social networks from Jaroslaw, Chief Architect from Krakow.
Used to be.
Meet him and we'll start.
You know, this is the presentation about Neo4j. Okay. Not Cassandra. Okay. So let's start with the story. Because what we do and what is the central part of our lives is code. You know, we are devotees in the Church of Code. We believe in code. Usually the code doesn't believe in us, but something simple. Yeah. You see this? The method works? Maybe. Method, and we are calling a static method, passing this. Okay? Simple. And because we are at the JET conference and we're supposed to talk about Java, you know what happens to this code? At some point of time, the JIT starts and will do the inlining. So basically we'll copy the bytecode for the method n into the body of method m, and we'll get this. Is it the same? My dear zombies, yes, it is the same, yes? Okay, what will happen next is the JIT will start another optimization, because it will never be true, this one, yeah? It never will be true. So we'll do something called null check folding, and we'll turn this code into this. Is it correct? It's still the same code. And then what will happen, we'll see the dead code elimination running, so we'll get this. Okay? So, is it the end? It's not, because at some point of time, if you use this switch, use fast empty methods, actually you will get empty everything, including there will be no stack pointer moved. And actually, this is the JVM code doing some nasty thing. And as you see, if the method is empty and you have the switch on, it will not increase the counter for the invocation counter. What? This is not this presentation. Okay. I will talk. Sorry, I have to. I love JVM, so whatever I'm talking about, I need a slide about JVM at the beginning. So, whatever we'll be talking today, we'll be talking today about graphs. And we'll be talking today about the Neo4j. Who knows Neo4j? Okay, who works with Neo4j? So you know we don't work. Okay, cool. I hope I will change it after this presentation. So, I'm rude. I'm from Poland. I'm a really rude person. So I need to introduce. I should introduce myself first. So I'm Jarek. I work in Krakow. Yes, I was a chief architect. Now I'm coding again. Yeah. So I'm working at Allegro, doing weird stuff with analytics, user profile, and behavior. Allegro is, you probably may know it, is the auction site and the retail site. And I'm doing the backend for some of the analytics and user profile. I'm also leading the program committee for JDD and for developers conferences and in Poland. Yeah, I love JVM, bytecode parsers, compilers, graphs, and all this kind of stuff. And I used to be manager, yeah, it was a sad part of my life, database admin, performance guy, and chief architect. That's all about me. Okay. What we'll do, I will try to do a really quick introduction and explain just the building blocks of graphs and Neo4j, and then I will move to code. Okay? Slides are boring. The one thing, because I speak fast, and I speak fast in Polish and even faster in English. If you don't understand, stop me, or you can, shout, slow down, and I will, I will try to slow down. Graphs. Who finished the university? Poor you. So basically, there is a definition of the graph, and graph is a ordered pair of blah blah compromising of together with blah blah blah. Yeah? And this is definition from Wikipedia. And in fact, it's pretty good, with small exception that it says that the edge is a set of 2-element subset of vertices. So the edge has the beginning as an end. It's not true because there is a special kind of graphs called hypergraphs, where edge can have many starts, many many vertices. There is not only one start and not only one end. But we are not going to talk about hypergraphs. So enough theory. Neo4j. What is this? It's a database written in JVM, of course, and it is based on the property directed graphs. So it implements the part of the graph theory, not everything, it will be hard. So you can have directed graphs with properties. What is important is, the Neo4j in 3 sentences. The graph is a record of nodes which have properties, and nodes are organized by relationships, so edges, and the relationships have properties as well. And of course, something that is pretty interesting is that you can have labels on nodes. So basically, to each node, you can give a label, whatever you want it. It's a string. And it helps you to group labels into sets. So if you say, give me all nodes which are city, because you can label a node city, it will return all cities in the database. Now, what is different comparing Neo4j and the usual graph databases? Neo4j is not an overlay. It's not an abstraction. It doesn't use MySQL underneath. It doesn't use Cassandra. There is a TitanDB. I don't know if you know it. This is a graph database which uses Cassandra as a storage. The thing is that with Neo4j, you have a special own storage mechanism developed by guys from the Neo4j, and to optimize the storage of nodes and edges. So, custom built database engine for Neo4j. So what we have in this database? What are the building parts of the database? The node. Every node has an ID. This is unique identifier of the node, and you can't set it. You can get it, but it is important part of the engine. So the ID is in the control of Neo4j, and it's long at the moment. You can have a set of labels, as many as you wish, and you can have properties. What's important, Neo4j is schemaless database, so you can have anything, anywhere. Then, so the node. Then the nodes are connected through relationships. So basically, every relationship has a type. I will explain. Just one type, not like labels. Direction, so the arrow, and of course, set of properties. Okay, so the relationship, the node, start node, and end node can be labels of these nodes. What else we have in this database? Of course, we have schema. I said schemaless database. So yeah, I don't like this name schema, but basically it's indexes. You can create secondary indexes. Underneath it uses Lucene, so you can do full text search on nodes because it's Lucene. And it has pretty simple constraints, yeah, like, I want this property to be unique in the whole graph. What are properties? Basically, there are Java primitives, long, int, float. You can have strings, and you can have arrays of the above. Pretty, I would say, small set of data. You don't have date. You can have objects, full-blown objects. It is all for speed. If you are going for a party tonight, I hope you, I can explain, and it will take a couple of hours, why they choose such narrow set of data types. You can live with it. Believe me, you don't need date, you don't need objects. You know this guy? Cypher. His name is Cypher, from Matrix. And they created language called Cypher. So for a long, long time, Neo4j had really nasty DSL Java API only to access the database, which was dirty, It was not nice. But I think it was version 2.0 when they said, okay, we need a language for graphs. They said SQL, okay, it's fine, but doesn't match to what we want to do with graphs, and doesn't match what graphs can do. There are languages like, for example, Gremlin, but they are like, you know, XPath for graphs. You show the paths, and we are working with graphs, much more complex structures. So they came up with the Cypher language. Quick introduction, and then we'll move to code. Basically, it looks like SQL, feels like pattern matching. The trick is that what you say in Cypher, and this is the way it is different from Gremlin, is you ask question, you know, find me a part of the graph, a subgraph, which matches my expression. Okay? You don't tell how you want to traverse this graph, like in Gremlin. In Gremlin, you show the steps. Get to this node, from this node, get this edge, from this edge, get this node, blah, blah, blah. And you just describe how you want to traverse. In Cypher, you say, find me a subgraph which matches my expression. So basically, the first one is really simple. Find me all nodes which have label, whatever the label is, and return it. It's simple. The next one is pretty fancy. Find me two nodes, as you say, one node and second node, which are connected with the relationship of type likes. Okay? The third one is stupid. Doesn't introduce anything. As you can see, this is what I like, is ASCII. You can have the arrows in any direction. You don't have to have arrows from left to right. You can have it from right to left. Even you don't need to have arrows. If you don't put arrow, it says in any direction. So I want to have nodes connected with the relationship, but I don't care if it's left to right or right to left. More complex examples is like, for example, find me the graph where there is connection between node A to B and from C to B. This one is funny. Find a node which is user and admin. Basically, it means it has label user and admin and has outgoing connection, outgoing relation to node B. Here, you see, it's like ranges. It says, find me node A and node B, but with two relationships between, so two jumps. You can, here is the donut. I call it donut because it just craves from the graph kind of donut. Yeah, 3 to 5 direction to 5 relationships between nodes. What is even more interesting is that patterns are expressions. So you can not only have them in the match part of the expression or of the query, but you can say also, you know, find me the node A with the relation rel with node B. Find me also the node C with label, but not B, which has relation to C. Okay? This is the fun thing I love, because the pattern, this part, returns a collection of paths. And if the collection of paths is empty, it evaluates to false. So you can use patterns in the match query, in the where. Of course, you can use it in return statements, and so on. Boring, it has collections, so you can create any kind of collections. You have, like in the last example, the list comprehension, looks like Python. So you basically say for every x in range from 0 to 10, where x is even, return x power 3. It has predicates. So basically you can say, for example, the third example, return the all nodes which has property name equal to sq, and where the array in this node contains in any position the string 1. Pretty expressive. You can have paths. And for example, the first query says return all nodes in the path. So all the nodes which were in the path or all relationships. Boring. I'm waiting for the code. Do you? Yeah. It has with clause. It's pretty funny. It works like a pipe in Unix. So basically you can create query and the results of the query pipeline to the next query. So you can have pipelining like here. Find me all users, all nodes which has property name equal to David, and they have relationship, any relationship if outgoing direction to any node, because you don't specify what this node is. And then return to the next query this other node and count the number of these relationships, and then you can filter and say, find me a person who has more than one friend. Okay, this is the query you will get here. The trick and a trap, and this is the trap I fall with my first project. I was thinking graphs, relations, relational databases. I don't know who invented the name relational databases. They are not about relations. So I designed my graph as tables in SQL. And this project, as usually, was disaster. Almost fired me. So this is important lesson. Think about graphs and don't think about SQL in context of Neo4j, because you will be writing Cartesian product queries, which kills Neo4j and any database if you have a Cartesian product. Yeah. So this is important lesson. If you are in graphs, think like you are in graphs. Don't think about tables. Don't think about SQL. Because what Neo4j is good at is about traversing the graphs. If you create your query as a traversation, so you go from node to node, it will work pretty fast. If you will do the Cartesian product or try to do joins, you will be hit by the lightning of the God's graph. Show me the code. I like this part because it doesn't usually work. So, what we have here is a console. It's not a database. It's the console to the database. Just start the Neo4j server, point it to the port, and you've got the console. You can start writing queries and playing with the database. What are we going to look at? Let's imagine for a moment when we are creating startup. Lots of money. Everybody has startup these days. If you don't have startup, you are probably over 40 like me. And this startup will be about trainings. So we will create a database of all trainings and all trainers in every country in Europe. And we'll try to find trainers and training for people. How you are modeling stuff in graphs? And this is my favorite part. Let me tell you a sentence. Yeah. Training Introduction to Spring Boot, authored by Tomasz Borek, requires some basic knowledge of Java, and it introduces you to Spring Core. This is a valid English sentence. I hope so. This is so what I did. I said, okay, the trainings will be nodes in the graph, and they will have probably property called title or name of the training. The trainers will be nodes as well, and they will have the name of the trainer. And here what we have is skills. Yeah, you need to know Java before the training, and after the training, probably somebody will upload you the Spring Core documentation into your brain. And this is why I like graphs, because you don't need special trainings in modeling. You don't need to know this fourth normalized form. Who teaches this at the university? Some freaks. Because I strongly believe if you are in the world of graph, the only skill you need to acquire is to be able to create sentences. It's hard for some people to create, sentences. Some people can't deal with such non-trivial task as create a sentence. But if you are able to create a sentence, you are able to model the graphs. The trick is, but sentences are pattern in the graphs. The nouns are vertexes and verbs are edges. And in most cases, 99.9 cases, because usually in our industry it depends, you will have a valid graph. What you can do with Neo4j is the Cypher. You can not only query the database, but you can also create nodes and create relationships. So this is a simple example. We are creating one node with the label training. We give this node a property title. Then we create another node with the trainer and two another nodes with the same label skill and the properties. And then we create the relationship between T0 and N0, so training and trainer, and training and skill with different types of the properties. Okay. Now I will do something that every programmer needs to know, is how to do copy pasting. Have you seen this book, The Introduction to Effective Stack Overflow Copy Pasting? It's sold in millions. Okay. So, yeah. Okay, not this one. There's one with color. So, in the evenings, my wife asks me, what are you doing? I am saying, I'm playing with balls. Because I will do this. You know what I like with database? I can spend hours. We can spend 45 next minutes, So, excuse me? Oh, the big one, yeah, this makes a mess. Okay, sorry. So, we have a bigger database with trainings, with trainers, and the skills. And the first query. Let's imagine the product owner comes and says, nice product, but we need a feature in this product. And this feature is, the person comes into the system, he says, I know Java, Assembler, and COBOL. It's like me, I know COBOL. And Java, it's the same. Sorry. And I know the skills. So now tell me which trainings I need to make to, for example, become master in Scala or master in Spring. So we have a pretty nice requirement. Finding what? The shortest path. Thank God Neo4j has the shortest path algorithm already implemented. There is a function called shortest path, and we show the shortest path between the skill Java and skill REST, and we just return the results. Yeah, copy pasting. Whoops. Next, okay. Formatting as usual. Bang, bang. Will it work? Match this path. Okay. Yeah. Okay. So if I want to be proficient with REST and I know Java, I need to first take the introduction. This is in Polish. Introduction to Spring Core, and after this introduction to Spring Core, I will have to do the microservices with Spring Boot, and I will be the master of REST. Yeah? Simple. Yeah. It was 2 years ago, almost. I was showing this at a conference in Poland, and I have really aggressive audience, it happens. And the guy from audience says, it's wrong. You know how I felt? 100 people in front of me, and they say, it's wrong. I say, oh my God, what's wrong? And it's actually wrong, this query. Why? Because first I say, let's find the skill with the name Java, and then let's find the skill with the name REST, and I did a shortcut. So basically find me the shortest path, and you can move only by relationship of type requires and relationship type introduces as many times as you wish, but because we don't know how many trainings we have, and we are done. What's wrong with this query? It's here, requires or introduces. So basically, I can have any combination of relationships, yeah? I can have requires, requires. Or I can have introduces, requires, introduces. And it's wrong, because what I want to is have requires Java, introduces skill, requires skill, introduces next skill. I want to have a pairs. And it always be introduces, requires, requires. Am I correct? Don't sleep. Am I correct? You have to. Am I correct? So, after this conference, I was like, wow, never ever gonna present this stuff. But in the evening, I said, okay, let's chat with the guys from Neo4j. We spent 2 hours, 1 beer, actually 2 on my side, trying to find the query which will behave like this, that I will have this interleaving types of relationships. So basically, this is my part, this is my contribution to the query, and this is the guys from Neo4j contribution to the query. So, the first thing, there will be always even number of relationships. It always will be requires, introduces. So always even number of relationships. So I filter and I say, okay, take all the paths, but remove the paths which are not even. Simple. Then is the question how to do like this. You know? Requires, introduces. So what we are doing here, we say, okay, we take the length of the path, -2 and range 2. Okay? So what we will have? 0, 2, 4, 6, 8, 10 in this collection. And then we say, okay, if the type of the first relation is introduces and the type of the next relation, so index +1 is requires, then it's okay. Nice? Nice, it fixes my problem. Yeah, I can show what it works and behaves as we expect. Yeah. Simple. Okay. This was just to get you familiar with the whole idea. Now I will show you something more complex, more interesting. My inbox, my Gmail inbox. You know, when you are a freak and your wife goes for a vacation or to see her mother with children and you're alone at home, what is your first thought? The first thought is, let's go for a drink. And I think it was February, and I said, oh, okay, I'm alone, nothing's going on. Let's call somebody. Maybe somebody has time and will go for a drink with me. And then I said, okay, so who should I call? Who should I choose to drink with? Yeah, Ghostbusters. I should call these people Ghostbusters. So I said, I don't know. So many people, so many friends. Let's see. So at the end, I didn't went for a party because I spent whole night importing my inbox into Graph. But basically, I imported the Gmail to Neo4j, and we'll play with it. So this is my graph after the import. What I have in my inbox, I have email addresses and messages. So this is what I can get. Basically, I say the message from this internet address was sent to this internet address, and this internet address, basically email, sorry, the name internet address comes from the JavaX mail package. It is internet address in this package. And I put CC this person on CC in this email. So what I have is just small subgraphs showing the mails and relation between the people who sent and received the email. Okay. Let's see this graph. What I'm doing is that I'm just changing the path to the database, so a little bit of copy pasting. It's funny to watch how people make mistake, you know, copy pasting stuff. Come on. Yeah, it's here. And let's restart the database. Did I save? Okay, I saved. You should see. So as you see, now I have different stuff in my database. I have internet addresses and messages. I have the black carbon copy and CC and from and to as relationships. Let's see what it is. It's pretty big database. It's not so big, 700. So I just changed the email addresses, okay? Just you don't know my friends. But I didn't change the titles of the emails. So basically, you have all of the emails with people who send it. Pretty nice. No, again, wow. What we can do from it? Yeah, it's a simple database, simple graph, not many facts. Just somebody sent to somebody. The trick is that you can get a lot of information from these simple facts. Let's start from the beginning. How the messages are related to each other. How can we find the email threads? Yeah? The trick is that every message in the protocol has the message ID and in replay 2 headers. So basically, we can connect every email to every email by matching the message ID to in replay header. You know this guy? Yours? Yeah, so materialize. This is the thing people in Neo4j community are talking a lot about. But basically, the main difference is that you materialize relationships. What happens in SQL is you have right table, left table, and every time you ask, you need to calculate. Of course, there are caches and all this stuff, but every time you ask, you need to calculate the relationship. It's different with Neo4j because the relationships are first-class citizens in the database. So you create relation, and they are. You don't need to recalculate them. How you do it? So basically, we can say, take all messages and take all messages, Cartesian product, but just once. And find me all messages and where message ID header is the same as the message in replay 2 header in message M, and create relationship between M to N, and give this relationship a type in replay 2. So we have a relation between two messages. Of course, it can take a while, so we can create indexes just to speed up this query, because it will be sequential scan anyway, so pretty expensive. Come on. Yeah. Chrome. Okay, one index and the copy paste of the second index. Yep, two indexes. Then you can go back to the query, copy paste it. Monkey can do this presentation. It can, pretty fast, 2 seconds. So just to prove it, that it actually created something, we have an in replay 2. new relationship. And as you see here, there are relationships between emails. Okay, this is I didn't pay the taxes on time. Yeah, happens. So you have relationships. What does it give us if we have relationships between emails? First, materialization. This is the weapon of mass destruction in Neo4j. You create relationships. You don't join every time. And we can ask the question, what is the longest email thread in my inbox? Can I ask this question now? I can. How? What is email thread? Okay? It is something where there is a first message and there are only relationships of in reply to type between messages, and there is the last message. The first message, how you recognize the first message? This is the message that doesn't have incoming relationship. What is the last message? This is the message which doesn't have outgoing relationship. How to write it in Cypher? Wow, far away. You can write it like this. Come on, stupid. So as you can see, I say find me the path. This is the way to find a path. You just simply substitute it, assign. Between message N and message M, and with any number of in replay to the relationships, but the message N doesn't have, yeah, and the message M doesn't have this one. Reads nicely? I think it reads nicely. Then I say, okay, so take this node N, I do pipelining, calculate the length of the node, and then return the next part of the query. So basically show me the subject and the length of the email thread. And of course sort it. You know Polish? So yeah, 52 emails over like half an hour called alkoholizacja, let's drink. We didn't get out, but this is the longest email thread in my email box. The question is for you now, just to think, I'm not an SQL expert, and I have one person in Krakow who says I can write it in Oracle. He said it to me 3 months ago, still didn't came to show it the query, so I'm just waiting. I just don't want to tell you that SQL is bad, yeah, but there are different data models better at different things. Okay. What you can do, of course, in Cypher is to have explain and profile, and it will show you how much time it will take to execute the query, and it will explain which indexes will be used. Explain in a pretty nice way. So you see, but it does the label scan using Lucene. Then it does the semi-apply between the nodes that were found, filtering, and it says estimated number of rows. So you can understand if your query is optimal. What is a kind of hint from person who used Neo4j a lot is that you need to be specific. It's really sometimes tempting to not put labels or not put relationship types, because you say, oh, in this graph there will be no relationship between this node and this node because the model says so. Yeah? It is better to put it, because when you change model, suddenly your queries start to work differently. And of course, it's good for the query planner to know which kind of labels and relationships you are going to traverse. So it's better to be really specific and say which kind of relationships and labels you want to traverse. What we get here, this is the essence of the presentation, not the Cypher and Neo4j, but this one, evolution of data. We started with this graph, and we are now here. Okay? Simple facts, and we build knowledge. There are facts, and on the facts, you build the knowledge, levels of knowledge, by one. So can we build another layer of knowledge in my inbox? What can you find? We can find friends now. Really? Let's make a small assumption, because every model is based on assumptions. The assumption is, if I know your email address, you are my friend. Okay? So basically, if I send email and I put Tomasz, Borek, and Kuba, and whoever on the email, it means that I know Kuba and I know Tomek. But if the Kuba responds to the email adding Piotr, it means that Kuba knows Piotr, but not necessarily I know Piotr. Okay? Let's make a friends. Come on. Now we have a new relationship, knows. And then we see in our graph who knows who. Okay? This is just one of the circles of friends. You see there is a limit 25, so you don't see the whole graph. We can change it and say, show me disappear. Come on. I don't want you. We can say no limit. Whoa. It's JavaScript. It renders 600 nodes. It may take some time. Yeah! Draw it. So this is my inbox. How this query works. And this is, I think, the good part. This is really visual. You see it. Basically, you say, I find message M, which has incoming relationship to message N, and the type relationship is in reply to, and this N message has two BCC or CC to R. But the R is not on to or CC or BCC to message M. You know, I exclude it. And then I say, okay, find me from, and then from this from, create relationship nodes to every R. So this one. Why merge? The trick is that you will have many emails between people. So if I do create, I will have as many relationships as emails people sending. Because every time I match, I will create a relationship. Merge basically says, create new relationship only if it doesn't exist. So it will create the relationship nodes only once. But there is no arrow. Yeah? It says, okay, create the relationship between R and F. If there is no relationship outgoing or incoming, I could put arrow here. It will then create in one direction. So what is the direction of the message, the relation, if it doesn't exist? It's from R to F. Simple, simple. We have friends. How do we stand with time? 5 minutes? No way. Okay. The evolution of the model. Look, this is our started graph. Nothing. It doesn't tell us anything. But now we have relations emails, and now we have this graph. Okay, we started from something simple to derive knowledge from facts. So where are my friends? I basically can use one of 3 techniques. I will show you one, and we'll try to negotiate time to tell you about 2. The first thing, I can try to find clusters. So the groups of nodes which are tightly clustered together. So basically where the number of relationships within this node is dense. How you do it? The one thing you need to know is that our graph is biased. Okay, I'm on every email. We can use clustering coefficient and just doing it really fast. Clustering coefficient is a number of connections between the neighbors with the number of all possible connections. So it says how close the graph is to a click. This is the math behind it. You read it as a poetry. But the query is like this. Whoa, my balls. Sorry, guys. No. Because it just calculated this parameter. Yeah. Oh, it's something wrong here. Where name exists. Okay, it's not this. I know what's the problem. Yep. There's one this problem. What's this? Oh, yeah. Okay. So, if you've got this parameter equal 1, it means that there is everybody is connected with everybody. So it's called a clique. It's like in politics and government. So this one is probably me. If you will have time, I will prove it that it's me, because I have the almost highest, except this is Tomek probably, and this is probably somebody else. So this is the way you can find neighbors in your graph. The last slide, I promise, because there are still like 60. You can use two additional techniques. One is called the strongly connected components, and there are Kosarahu and Tarian algorithms. And of course, there is a special set of algorithms to detect the clicks. So it not only returns you the value of density, but finds you the nodes which are in click. Questions, because there is one more example, but I never did it in full.
So we have time for questions. Please raise your hands. Okay, I see. Also, remember about free beer tickets.
Oh yeah. Oh God.
Hey, my name is Igor. So when you create new relationships and you have an error, how you undo those relationships?
I create the new relationships and I want to remove them. Yes.
Yeah.
It's just you simply do delete. So for example, I can say find me a node which has relationship with another node, yeah, and then I can say delete R, okay? Then
okay.
I remove the relationship.
Yeah, thanks.
Hi, my name is Alex. Could you please explain, is it possible, for example, distincting answer by different parameters? For example, you need to find possible friends in your graph, but all these friends should be as much as possible from different cities, for example. Is it possible such queries to run? Do you understand my question?
Yeah.
Okay, thank you.
So basically you can say that you have friend 1 and they are in a relation, so nodes, yeah, with another friend, and then you can do two tricks. Shit. You can say return distinct. Okay, by the query by the node ID, or you can say by the name, city name, for example. You can do like this. You can also do it like, where is my query? You can also say match A to B, where B city, for example.
But I will receive with distant cities, correct?
Different cities.
Yes, I mean, for example, I need one friend from Berlin, but all other friends from Frankfurt. So my goal is receive friends all from every city is different friend if I have.
Okay, so you can do it, but it's then you will have to create cities as nodes, not as properties, but as nodes. And for example, you can say, find me one friend from, for example, Germany. So what you do, you create cities, and cities have relationship to Germany as a country. And say I don't know, Krakow is a city in Poland. And then you can create queries and say, okay, only one node which has a relationship to this country.
So another question?
Hello, I'm Maxim. My question, can we use Neo4j as distributed database, something like HBase or...
Yes and no. So, first thing, the open source version doesn't have any, slave master. It's just a single node. So it can handle a large number of nodes, but it's a single node. With the enterprise version, you have higher availability where you can have a master slave and this way distribute the data. If you think about partitioning, it's graph. So it's pretty hard to partition the graph. So at the moment you are not able to have a situation when the part of the graph is on another machine. So this way you can't distribute it.
Okay, thank you. What about the replication mechanism?
Yeah, you have a replication with the enterprise version. When you have the master, everybody writes to master, and it's distributed to slaves. This is like the basic MongoDB scenario as well. Yeah?
Thank you.
So you can distribute load, but you can't partition the graph at the moment.
Some questions more? Okay, the last one.
Give it to me, guys. I will be at the party, so with my laptop, so I can show you the last example.
One question. So do you use Neo4j together within GTA transactions, together with, for example, some queries to Neo4j and some queries unique to the relation in the database, or you use it independently?
I use it independently. Of course, I can use it. The only thing I was doing with JTA, because I didn't tell you, Neo4j is two-phase transactions. You can hook it into one transaction. We were getting the messages from the network over JMS and putting the information. We were not playing with, for example, Oracle and Neo4j in one transaction, but you could do it.
So, thank you for presentation. I don't know how you will share your beer tickets.
I don't know.
It's up to you.
I would distribute it.
Just share. Okay, thank you all guys to be here. Thank Jaroslaw.